I believe this one's going to be a short one. We're looking at the probability of and events here, and that's pretty simple. Instead of just saying the outcome is one thing, we're saying it's one thing and another thing. What's the probability that it fits two categories? And let's look at coin really quickly here. This is going to be a short one. If we flip the coin, what's the probability that it lands on both heads and tails? Well, that is not going to happen, right? There is no outcome that it fits both descriptions. It's either a head or a tail. So there is no chance that we're going to get both. And we call those two events mutually exclusive. Okay, more vocabulary. You do need to understand what mutually exclusive means. It's very simple. It just means that those two things cannot both occur in the same event. So you cannot flip a coin and have it land in the same event on both heads and tails. Mutually exclusive means they exclude each other. If one happens, the other can't, etc. And everything, or all of our events, are mutually exclusive with coins, so we're not going to worry about coins here. Same thing's true with dice, right? You can't flip something that is a 6 and also a 3, so not going to be terribly interesting. So we're going to stick here with the deck of cards and the tables. Now remember, the deck of cards has 4 suits: hearts, diamonds, clubs, spades, and you don't really need to know which one's which. Just remember the clubs and the spades are black, and the hearts and the diamonds are red. So if we pick a card at random from the deck, what is the probability that it will be an ace and will also be a heart? Well, how many cards are there that fit both descriptions? Remember, probability is just going to be the number of successes over the number of possible outcomes. The number of possible outcomes is 40 because there's 40 cards in the deck, and that's going to be true whenever we're talking about drawing a card from our special deck here. How many of those are ace of hearts? Just one. So our probability there is going to be 1 out of 40. What's the probability that our card drawn at random will be a 10 and also red? Well, there's 40 cards in the deck. And how many of them are red 10s? Well, there's a 10 in each suit. 2 of the suits are red, 2 of the suits are black. So that means 2 of our 10s are going to be red. That's 2 out of 40 or 1 out of 20 or 0.05. Fractions are fine. Decimals are fine. You can even say 5% there if you want. I'm fine with either form of those, whichever one works best for you in a particular context. What's the probability that a card drawn at random will be an ace and a 10? Well, that's not possible, right? There's no card that is an ace and a 10, so that's going to be 0 out of 40 or just plain 0. Remember, we call those two events mutually exclusive. We cannot have a card that fits both of them. And what's the probability we get a card that's greater than 5 and is red? Well, that's going to be 6, 7, 8, 9, and 10. That's 5 from both the diamonds and the hearts. So that's going to be 10 out of 40, which is going to be 0.25 or 25%. Expression is up to you. Okay, told you this was going to be pretty easy. Let's do a little bit more. Let's get our table here of our statistics loving and hating boys and girls. In this table, or if we pick a person at random from this population, what's the probability that they will be a boy and that they will love statistics? Well, that's going to be just the people in this box here. So the 10 of those out of the 100 total, and that's going to be just 0.1. What's the probability that we get a girl who loves statistics? Well, that's just this box here. That's going to be 30 out of 100. So that's going to be, not even going to bother writing it, it's going to be 0.3. What's the probability that we get a boy who doesn't love statistics? That's going to be these boys here. They're in the boy row in the not loving statistics column. That's going to be 2 out of 100. So that's going to be 0.2. And lastly, the trick question. What's the probability that the person we pick both loves and does not love statistics? Well, those are our mutually exclusive events. Can't both love and not love statistics, even though I suspect that at this point in time, many of you are walking the line between those two things. So we're going to say 0 there. We're going to see those are mutually exclusive. Right? So probability of and events Very simple. All we have to do is pay attention to the descriptions, the two different characteristics, count how many successes there are, how many things in our population fit both of those characteristics, divided by how many things there are in the population as a whole.